Assalamualaikum and hello. Let's continue with the next physical properties of carboxylic acid, which is solubility of carboxylic acids in water. So there are two factors that affecting the solubility of carboxylic acid, which are the first one, their ability to form hydrogen bonds with water molecules, and the next one is size of the molecule. I'm going to focus one by one. If you know that carboxylic acid as general, I can write it down as RCOOH. The first one you have is C double bond O, as we know that as carbonyl group, and the other one is OH group that attached to single bond C. This one we know it as hydroxyl group. So both of these make up as carboxyl group. So when you have COOH, COOH can form hydrogen bonds with the water molecule. For example, I have this water molecule that can form the attractive forces between hydrogen atom from water with oxygen atom from carboxylic acid. So this is the attractive forces that we call specifically as hydrogen bond. You can also see that oxygen from hydrogen can also form another hydrogen bonding with hydrogen from COH side of your carboxylic acid. So you can see a lot of attractive forces here that can form by two ends of the chain. The first one is from carbonyl group and the second one is from hydroxyl group. That what makes carboxylic acid is very special compared to alcohol. So when you have higher number of carboxyl group in your structure of molecule, you can say that it can form more hydrogen bonds with water molecules, making the solubility in water increases. So if you have different structures of carboxylic acid, you have to take a look how many carboxyl group in that structure, and if you got more than one, so of course it can form more than one hydrogen bonding. So that's why the term more here is very important that you need to emphasize in your explanation. Please take note the most important thing about solubility of carboxylic acid in water, we never ever talk about dimerization in solubility, because dimerization only can be used during our explanation of boiling point. So now we are talking about solubility, so just about the hydrogen bonding with water molecule. So please take note about that. Now we go to the second factor that affecting the solubility of carboxylic acid in water, which is size of molecule. So if you got two different size of molecule, for example, one of them got a larger size or higher molecular weight, so this one refers to the number of carbon atoms in that carboxylic acid. So we are referring to the alkyl group here. So it means that that molecule contains larger size of alkyl group, giving larger hydrophobic area. So that's why the solubility in water decreases for molecule that has larger alkyl group, because it contributes to larger hydrophobic area. So that's why when you talk about this case, you are talking about hydrophobic area and hydrophilic area here. Hydrophilic means it loves the water molecule, but hydrophobic area means it hates water molecules. So that's why if you got a longer alkyl group, it can form larger hydrophobic area. So that's why your solubility in water decreases, or it takes longer to dissolve. So I hope all of you understood about two factors here. Let's focus with another additional information in the next page. So now we are talking about different number of carbon atoms in your carboxylic acid. For your information, if you got carboxylic acid with one carbon atom until 5 of them, you have to know that they are completely soluble in water. So the chances of their solubility is higher in water. But if you got carboxylic acid with 6 carbon atoms and above, they are quite insoluble in water. So why this happen? Because if you got aliphatic carboxylic acid with more than 5 carbon atoms, you know that they are insoluble in water. But if you have carboxylic acid with 6 carbon atoms and above, you have to know that they are insoluble in water. So now I'm going to divide into 3 categories so that you can understand more how to detect the solubility of carboxylic acid based on their different structures. The first one, aliphatic carboxylic acid with more than 5 carbon atoms are insoluble in water. That is the first statement. The second one, if you got aromatic carboxylic acid, they are slightly soluble in water at room temperature. This is because of huge size of aromatic ring here. If you see here, when we talk about aromatic carboxylic acid, it means that it has benzene ring attached directly to the carboxyl group. So this size of benzene ring is very big, that contributes to bigger hydrophobic area. So the size is very bulky. So this is another term that you can use in your explanation to show how big the aromatic ring can affect the solubility of carboxylic acid in water. Next one, you have dicarboxylic acid. So it means that in one structure of your carboxylic acid, you have 2 carboxyl groups because you use di here, and they are relatively more soluble in water because they can form more hydrogen bonding with water molecule. You can see from this structure. So dicarboxylic acid is the highest in terms of solubility in water. So I hope all of you understand now how to detect which structures of carboxylic acid, either they are aliphatic or aromatic, and how their size and ability to form the hydrogen bonding can affect their solubility. So that's it for this video. I'll see you for the next one in the next video. Thanks for watching. Bye.